Hello everyone, this is Revathi M, Assistant Professor, Department of Computer Science, Artificial Intelligence and Data Science, Dr. SNS Rajalakshmi College of Arts and Science. In this series, we discussed about the theoretical fundamentals of artificial intelligence. So today we are going to discuss about the arithmetic predicates in Prolog. So in Prolog, arithmetic predicates are built-in predicates used to perform mathematical calculations and comparisons. Since Prolog itself does not automatically evaluate arithmetic operation, these predicates are necessary to computer values, compare numbers and reason with arithmetic numbers. So these are the arithmetic, we will see the sum of the arithmetic expressions. First one is a his by 2. It evaluates arithmetic expression. So here this is predicate is used to evaluate the right hand side expression and assign its value to the left hand side. For example, x is 3 plus 5. Here percentage of x equal to 8, y is 7 into 2. Percentage of y equal to 14. So here x is 3 plus 5. So percentage of x equal to 8. Then y is 7 into 2. So percentage of y is equal to 14. So these are the evaluate arithmetic expression. Next one is the comparison predicates. So these are greater than by 2, less than by 2, greater than or equal to by 2, equal to less than by 2. So these are all the comparison. For example, 7 greater than 3. So here percentage is true. So for another example, 4 less than 10, it's a percentage is true. Next one is a equality and inequality. So equality inequality symbol is equal to by 2, equal to slash by 2. So these are all the operator of equality and inequality. For example, 3 plus 2 equal to 5. So here percentage true since both evaluate the 5. Next, the comparison predicates. So here we will see some example. Equal to by 2 is the unification, x equal to y. So the, tries to make two terms the same by binding variable if possible. So for example, x equal to y, percentage of x and y become the same variable. So x equal to 5, the percentage of x is unified with the 5. So slash equal to slash 2, it's a not identical, meaning succeed only if both terms are already exactly the same. So no variable bindings. So these are, it's a not identical, it cannot be unified. These are all the operators we are using the comparison predicates. Next one is a control predicates. Control predicates in Prolog are special built-in predicates that control the flow of execution rather than performing calculations or comparisons. These predicate true or always 0 succeed regardless of the context and is often used as a placeholder in ruler where no condition is required. In contrast, false is slash 0 always fails. So it's always succeeds. So false slash 0 is always fails, which can be useful for testing condition or forcing Prolog to backtracking and explore alternative solution. So the cut, here the cut we are using. So operator, cut operator is a powerful control predicate that commits Prolog to the choices made up to that point, preventing backtracking beyond the cut. This is commonly used to improve efficiency and ensure deterministic behavior in rules. Finally, the disjunction operator. So it's called as a semicolon slash 2. This is the disjunctive operator. It gives or. So allow Prolog to choose between alternative paths. If the first option fails, it tries to second. Together, this control predicates gives the option fails. It is tried the second. Together, this control predicate give the programmer fine control over how Prolog explores and execute possible solutions. Next, we see the type checking predicates. So type checking predicates are built-in tools used to test the nature of terms and verify the data types. So the predicate variable of x it succeed if x is uninstantiated variable, meaning no value has no assigned yet. Conversely, non-variable of x. If x is already has a value or structure assigned, that is, it is instantiated. The predicate integer of x is true if x is a integer value, which is useful when working with the arithmetic operator and ensuring numeric inputs. Next one is a integer. So integer of x, it's a true if x is an integer. Next one is a atom of x. If it is true if x is an atom. Number of x true if x is a number. So these are all the type checking predicates are essential for writing robust Prolog programs, as they help in validating data, avoiding errors, and guiding logical reasoning based on the type of terms involved. Next one is the input-output predicates. In Prolog, input-output predicates that allow interaction with the user by displaying information or accepting input. The predicates write one, so it's a print output. Is used to print output on the screen. For example, write hello world will display the message hello world when executed. So next one is a NL by 0. It's a new line. So it's created the new line in the output, ensuring that the subsequent text appears on the next line, which is helpful for formatting result neatly. Finally, the read/1. So it's read input from the user. It's used to accept input from the user. For instance, if we use read of x. Next, we see the some examples. Input-output predicates are used to interact with the user. The predicate write one prints in output. So here, check age of age, integer of age greater than or equal to 18. If the condition is true, write eligible. It's a NL is represent a new line. So these are the example for the input-output predicates. So we come to the end of this section. I hope you enjoy this section. Thank you.